So as mentioned in the email this video is attached to, Dr. Elaine drops a pile of roof shingles from the top of a roof located 8.52 meters above the ground. Determine the time required for the shingles to reach the ground. Well, I solved this problem using like a step-by-step process. So to just begin to find the solution for this problem, I drew a diagram to illustrate what's going on here. And then the second step involves the identification and the listing of the information that I already know, and which you might be able to see that in the statement of the problem, there's only one piece of numerical information explicitly stated, and that's the 8.52 meters that the shingles fall. So we're going to have to infer a few values here. So the displacement of the shingles has to be negative 8.52 meters, which that negative sign just kind of indicates that it's falling down. So the remaining information can be extracted from the problem stated based upon the understanding of the above principles. So the initial velocity value can be inferred to be 0 meters per second since the shingles are dropped. And the acceleration of the shingles can be inferred to be negative 9.8 meters per second squared since the shingles are free falling. Now the next step of the solution is going to be to identify which kinematic equation needs to be used here. And again, there's 4 kinematic equations in total. And the one I chose was D is equal to VI times T times 1/2 of the times acceleration times the time squared. And once I know this equation, the next step of the problem is to substitute the values that I know into the equation and use the proper algebraic steps to solve for the answer. So I get that negative 8.52 meters is equal to 0 meters per second times the time plus 1/2 times negative 9.8 meters per second squared times the time squared. And after plugging all my values in for that, I get the time out to be 1.32 seconds.